JavaScript. So let's start with the first question. What is JavaScript? JavaScript is one of the most popular and widely used programming languages in the world right now. It's growing faster than any other programming languages, and big companies like Netflix, Walmart, and PayPal build entire applications around JavaScript. And here's the average salary of a JavaScript developer in the United States. That is $72,000 a year. So it's a great opportunity to get a good job out of learning JavaScript. You can work as a front-end developer, or a back-end developer, or a full-stack developer who knows both the front-end and the back-end. Now the second question, what can you do with JavaScript? For a long time, JavaScript was only used in browsers. You can build full-blown web or mobile apps, as well as real-time networking applications like chats and video streaming services, command line tools, or even games. Here's an example. The third question, where does JavaScript code run? JavaScript was originally designed to run only in browsers. So every browser has what we call a JavaScript engine that can execute JavaScript code. For example, the JavaScript engines in Firefox and Chrome are SpiderMonkey and V8. In 2009, a very clever engineer called Ryan Dahl took the open source JavaScript engine in Chrome and embedded it inside a C++ program. He called that program Node. So Node is a C++ program that includes Google's V8 JavaScript engine. Now with this, we can run JavaScript code outside of a browser. So we can pass our JavaScript code to Node for execution. And this means with JavaScript, we can build the backend for our web and mobile applications. So in a nutshell, JavaScript code can be run inside of a browser or in Node. Browsers and Node provide a runtime environment for our JavaScript code. And finally, the last question. What is the difference between JavaScript and ECMAScript? Well, ECMAScript is just a specification. JavaScript is a programming language that conforms to this specification. So we have this organization called ECMA, which is responsible for defining standards. They take care of this ECMAScript specification. The first version of ECMAScript was released in 1997. Then, starting from 2015, ECMA has been working on annual releases of a new specification. So in 2015, they released ECMAScript 2015, which is also called ECMAScript version 6 or ES6 for short. This specification defined many new and so on. Out of these, my favorite is Visual Studio Code that you can download from code.visualstudio.com. It's a very simple, lightweight, cross-platform, and powerful editor. So if you don't have Visual Studio Code on your machine, go ahead and download it. The other thing I want you to install is Node. You can download Node from nodejs.org. Now, technically, you don't necessarily need Node to execute JavaScript, because as I explained before, you can execute JavaScript code inside of a browser or in Node. But it's good to have Node on your machine because we use that to install third-party libraries. And also later in this section, I'm going to show you a preview of Node. So pause the video now and download Visual Studio Code as well as Node. Once you're done, come back, continue watching. All right, now I want you to create a new folder. Call that JS-Basics. The name doesn't really matter. We just want to have a folder for writing all the code in this course. Now, drag and drop this folder into Visual Studio Code. Okay, we've got this folder open. Let's add a new file here, index.html. Now, you don't really need to know HTML in order to take this course, but if you want to be a front-end developer, you should know your HTML well. Now, in this file, I want you to type an exclamation mark and then press tab. This generates some basic HTML boilerplate. We don't really care about any of this code here. We're going to use this as a host for our JavaScript code. You're going to see that in the next lecture. So save the changes. Now open the extensions tab here. Here in this box, search for live server. So live server is a very lightweight web server that we're going to use to serve our web application. So install this, then you will have to restart Visual Studio Code. When you're done, go to the Explorer tab, right-click index.html, and select Open with Live Server. This will open up Chrome or your default browser and point it to this address. That's where our web application is served from. Now currently we have an empty page. Now to make sure that everything is working properly, let's go back to Visual Studio Code. Here in the body section, let's add an H1, press Tab and type Hello World. Now save the changes. Back in the browser, you can see this page is refreshed automatically, and we've got the Hello World heading here. In the next lecture, you're going to write your first JavaScript code. In order to write JavaScript code here, we need a script element. There are two places where we can add a script element. We can add that here in the head section, or in the button, I'm going to type script and press tab. This is our script element. Now, why did I say that as a best practice, you should put the script element here? Well, there are two reasons for that. One reason is that the browser parses this file from top to bottom. So if you put the script element here in the head section, you might have a lot of JavaScript code there. So your browser may get busy parsing and executing that JavaScript code, and it won't be able to render the content of the page. So this will create a bad user experience. Your user looks at your web page, it's white or blank, while your browser is busy parsing and executing your JavaScript code. So that's reason one. The second reason is that almost always the code that we have in between script elements needs to talk to the elements on this web page. For example, we may want to show or hide some elements. So by adding the code here at the end of the body section, we'll be confident that all these elements are rendered by the browser. Now, there are exceptions to this rule. Sometimes you're using third-party code that has to be placed in the head section. But these are exceptions. As I told you before, as a best practice, you should add your JavaScript code at the end of the body section. Now here, we're going to write the same code that you wrote in the last lecture. Console.log hello world. But we're going to talk about this in a little bit more detail. What we have here is a statement. A statement is a piece of code that expresses an action to be carried out. In this case, we want to log a message on the console. All statements in JavaScript should be terminated by a semicolon. What we have here in between single quotes is called a string. A string is a sequence of characters. Now in JavaScript, we also have this notation. We can add 2 slashes, and this represents a comment. So here we can add some description to our code, and this description is ignored by the JavaScript engine. It's not executed. It's purely for documenting the code when you want to explain to other developers why you have written this code this way. You don't want to explain what the code does because that should be clear in the code itself. So here I don't want to write something like logging something on the console. That's so obvious in the code, right? Instead, we want to explain whys and hows. So for this demo, I'm just going to add a simple comment. This is my first JavaScript code. Now save the changes. Back in the browser, we need to bring the console back up. So right click somewhere and go to inspect, or alternatively, you can use a shortcut that is Alt Command and I on Mac or Alt Control I on Windows. That brings up the console tab. If the console tab is not immediately visible, make sure to select it here. And here you can see the hello world message. While we can easily write JavaScript code in between the script element, in a real-world application, we have thousands or even million lines of code. We don't want to write all that code inline here. We want to extract and separate our JavaScript code from our HTML code. Let me give you a metaphor. Think of your house. In your bedroom, you have your bed and your clothes. You don't store your clothes in the kitchen. This is what we call separation of concerns. We have the same principle in programming. So we want to separate HTML, which is all about content, from JavaScript, which is all about behavior. How should your web page behave? What should happen when we hover our mouse over a given element. Maybe something should pop up, maybe something should be hidden. So we use JavaScript to implement behavior. So open up the Explorer window, add a new file, call it index.js. Now, back in index.html, cut all this JavaScript code here, and then paste it in index.js. Now, in this simple application, we have a single file, a single JavaScript file. In a real-world application, we have hundreds or even thousands of JavaScript files. Later in the course, you will learn how to combine these files into a bundle and serve that bundle to the client. Now, save the changes, back in index.html. Now that all our JavaScript code is in a separate file, we need to reference that file here. So let's add an attribute here, src, which is short for source, and set it to index.js. So this tells the browser that our JavaScript code is now in index.js. Save the changes, back in the browser. You can still see the hello world message, and that confirms that our code is still working. In the next lecture, we're going to execute this code in Node. Executed this piece of JavaScript code inside of a browser. In this lecture, I'm going to show you how to run the same code in Node. So I'm assuming that you have installed Node on your machine. If not, head over to nodejs.org and download the latest version of Node. Now, if you're on Windows, open up Command Prompt. If you're on Mac, open up Terminal and head over to the folder you created earlier. Now in this folder, we run node and pass the name of our JavaScript file, that is index.js. We get the same message on the console. So you can see Node is a program that includes Google's V8 JavaScript engine. We can give it a piece of JavaScript code and it will execute that code for us, just like how we can execute some JavaScript code in a browser. So Node is a runtime environment for executing JavaScript code. Now let me show you a tip. Here in VS Code, we have an integrated terminal, so you don't have to explicitly open up a separate terminal window. So here on the top, under the View menu, look, we have integrated terminal. Note the shortcut here. That's the shortcut for Mac. On Windows, you're going to have a different shortcut. So select this, and here's our integrated terminal pointing to the same folder where we created our files. So you don't have to explicitly navigate to this folder. And here we can run node index.js as well. Now in this course, we're not going to work with Node anymore because Node is a completely separate topic. In fact, I have a comprehensive course about Node with 14 hours of content. So once you finish this course, if you want to learn Node, you can always look at my Node course. In a computer's memory. So we store our data somewhere and give that memory location a name. And with this name, we can read the data at the given location in the future. Here's a metaphor. Think of the boxes you use to organize your stuff. You put your stuff in various boxes and put a label on each box. With this, you can easily find your stuff, right? A variable is like a box. What we put inside the box is the value that we assign to a variable, that's the data, and the label that we put on the box is the name of our variable. Now let's see this in code. So here in index.js, I'm going to declare a variable. Now previously in the old days, before ES6, we used the var keyword to declare a variable. But there are issues with var, as you will find out later in the course. So going forward from ES6, the best practice is to use the let keyword to declare a variable. Now we need to give this variable a name or an identifier, and this is like the label we put on a box. So I'm going to call this name, and finally we need to terminate this declaration with a semicolon. Now let's log this on the console and see what we get. So console.log name. Once again, we need to terminate this statement with a semicolon. Save the changes, and here in the console we see undefined. So by default, variables that we define in JavaScript, their value is undefined. Now we can optionally initialize this variable. So I'm going to set this to a string, which is a sequence of characters, like Mosh. Note that I'm using single quotes. You can also use double quotes. Different developers have different preferences, but it's more common to use single quotes for declaring strings in JavaScript. Now, when we save the changes, instead of undefined, we see mosh on the console. So here in this example, we have declared a variable called name, and we have set that to this value, to this string. Now, we have a few rules for naming these variables. Here are the rules. First is that they cannot be, if you try to use one of these names, you're going to get an error. For example, if I change this to if, note this red underline. This is indicating that this is not a valid identifier, okay? So revert it back. Now, the second rule is that they should be meaningful. We want to have meaningful names, like meaningful labels. I've seen developers using names like A or B or A1 or I don't know, X. These variable names do not give us any clue what is the purpose of these variables. What kind of data are we storing at that memory location? So always use meaningful and descriptive names, okay? Now, back to name. The third rule is that they cannot start with a number. So we cannot have a variable like one name. But again, going back to the second rule, why would you want to call a variable one name? It's meaningless, right? So always use meaningful names. The fourth rule is that they cannot contain a space or hyphen. So if you have multiple words, you need to put them together. Here's an example. Let's imagine we want to declare a variable called first name. So first name, and note that here I'm using camel notation. So the first letter of the first word should be lowercase, and the first letter of every word after should be uppercase. This is what we call camel notation, which is the convention we use in JavaScript to name our variables. Another thing you need to know about these variable names is that they are case sensitive. So if I declare another variable, call it first name, but make the F uppercase, these two variables are different. But as I told you before, if you stick to camel notation, you wouldn't end up with a variable name like this. And finally, the last thing you need to know about these variables is that if you want to declare multiple variables, there are two ways to do this. You can declare them on one line and separate them using a comma. So first name and then last name. Now in this case, I have not initialized either of these variables. They're both undefined. I can optionally initialize one or both of them. So I can set this to Mosh, and I can leave last name undefined or set it to my last name, Hamedani. But the modern best practice is to declare each variable on a single line. So we terminate this first declaration with a semicolon and declare the second variable on a new line. That's the modern best practice. Next, we're going to look at constants. Variable called interest rate. So let interest rate, and we set this to 0.3. Now this is the initial value. We can always change that later. So we can set interest rate to, let's say, 1. Now if we log this on the console, of course we're going to see the new value, right? So save the changes, and here's 1 on the console. However, in a real-world application, there are situations that we don't want the value of a variable to change, because otherwise it's going to create all kinds of bugs in our application. In those situations, instead of a variable, we use a constant. So the value of a variable, as the name implies, can change, but the value of a constant cannot change. So here, if we change let to const, now interest rate will be a constant. So when I save the changes, you're going to see an error in the console on line 3 where we reassign interest rate. So let's have a look. Save the changes, and here's the error. Uncaught type error, assignment to constant variable. You can see this error happen in index.js, line 3. Now if you click here, you can see the line in code where this error occurred. So we cannot reassign a constant. All right, now back to the console. So here's the best practice. If you don't need to reassign, constant should be your default choice. Otherwise, if you need to reassign a variable, use let. How to declare and initialize a variable. Now you might be wondering, what are the kind of values that we can assign to a variable? Well, you have seen strings, but we have more types. Basically, in JavaScript, we have two categories of types. On one side, we have primitives, also called value types. On the other types, we have reference types. In this lecture, we're going to focus on primitives, and you're going to learn about reference types later in the course. Now, in the category of primitives, we have strings, numbers, booleans, undefined, and null. Let's look at each of these in action. So here we have a variable called name, which is set to a string. What we have here is what we call a string literal. That's just a fancy name for a string. Now let's declare a variable and set it to a number. So let age, we set that to 30. And by the way, I'm not 30 years old, but don't tell anyone, okay? So this is what we call a number literal. Now let's declare a boolean. A boolean can be either true or false. So let is approved to be true. This is what we call a boolean literal. And we use this in situations where we want to have some logic. For example, if the order is approved, then it needs to be shipped. So the value of a boolean variable can be true or false. And by the way, note that both true and false are reserved keywords, so they cannot be variable names. Okay? Now you have seen undefined before, so I can declare another variable, first name. If we don't initialize it, by default, its value is undefined. But we can also explicitly set this to undefined. But that's not very common. In contrast, we have another keyword that is null. So let me declare another variable and set this to null. We use null in situations where we want to explicitly clear the value of a variable. For example, we may want to present the user with a list of colors. If the user has no selection, we want to set the selected color variable to null. In the future, if the user selects a color, then we're going to reassign this variable to a color like red. And then if they click red again, perhaps we want to remove the selection, so we set this back to null. So we use null in situations where we want to clear the value of a variable. So these are the examples of primitives or value types. We have strings, numbers, booleans, undefined, and null. Now in ES6, we have another primitive that is symbol, and you're going to learn about that later in the course. Types of programming languages: static languages or dynamic languages. In static languages, when we declare a variable, the type of that variable is set and it cannot be changed in the future. In a dynamic language like JavaScript, the type of a variable can change at runtime. Let's see this in code. So back in the example from the last lecture, we have declared this name variable and we have set that to a string. So the type of name is currently a string, but it can change in the future. Let's take a look. So here in the console, we can execute some JavaScript code. We have this type of operator, and with that, we can check the type of a variable. So after that, we add the name of the variable, in this case, our name variable. So note that the type of name is a string. Now, if we reassign name to a different value, like a number, and check its type, look, the type is now changed to a number. This is what we call a dynamic language. So unlike static languages, the type of these variables will be determined at runtime based on the values that we assign to them. Now let's take a look at a few more examples of the type of operator. And by the way, note that type of is another reserved keyword, so you cannot have a variable called type of. So we can clear the console by pressing Ctrl and L. So now let's take a look at type of age. It's a number. Now if we change age to a floating point number, and I know it doesn't make sense, but let's just stick to this for this example, 30.1. And then look at type of age. Now let's look at the type of is approved. It's a boolean, as I told you before. What about the first name? Let's have a look. Type of first name. It's undefined. And that's funny because the value of this variable is undefined, but its type is also undefined. What does this mean? Well, earlier I told you that we have two categories of types. We have primitives or value types and reference types. In the primitive types category, we have strings, numbers, booleans, undefined, and null. So undefined is actually a type, but it's also a value. In this example, because we have set first name to undefined as a value, its type is also undefined. Okay? Now, what about selected color? Let's have a look. So type of selected color. The type of this variable is an object. What is an object? That's the topic for the next lecture. We have objects, arrays, and functions. In this lecture, we're going to explore objects, and you will learn about arrays and functions later in this section. So, what is an object? An object in JavaScript and other programming languages is like an object in real life. Think of a person. A person has name, age, address, and so on. These are the properties of a person. We have the same concept in JavaScript. So when we're dealing with multiple related variables, we can put these variables inside of an object. For example, here we have two variables, name and age. They're highly related. They are part of the representation of a person. So instead of declaring two variables, we can declare a person object. And then instead of referencing these two different variables, we can just reference the person object. It makes our code cleaner. So let's see how we can declare a person object. We start with let or const if we don't want to reassign the person object, and set it to an object literal. So this syntax we have here, these curly braces, is what we call an object literal. Now, between these curly braces, we add one or more key value pairs. So the keys are what we call the properties of this object. In this case, we want this person object to have two properties or two keys, name and age. So we add name here, that's the key. Then we add a colon, and after that we set the value. So mosh. Now we add a comma and add another key value pair, age 30. So now we have a person object with two properties or two key value pairs, name and age. And with that, we don't need these two variables. Now let's log person on the console. So console.log person. Save the changes. So here's our person object. Again, note the object literal syntax. So we have curly braces, and in between them we have one or more key value pairs. And these are the properties of the person object. Now, there are two ways to work with these properties. Let's say we want to change the name of this person. So we need to access the name property. There are two ways. The first way is what we call the dot notation. So we add the name of our object, in this case person, dot. Now you can see its properties. We have age and name. So we can change the value of name to John. Now we can use the dot notation to also read the value of a property. So here on line 10, instead of logging the person object, we can log its name property. Now save the changes, and in the console we get John. The other way to access a property is using bracket notation. So bracket notation. So instead of dot, we use square brackets, and we pass a string that determines the name of the target property. So single or double quotes, but single quotes are more common. The name of the target property is name. So we can change that to, let's say, Mary. Again, when reading that, we can use the dot notation or the bracket notation. If we save the changes, now we get Mary on the console. Now you might be asking, which approach is better, dot notation or bracket notation? Well, as you can see, dot notation is a bit more concise, it's shorter, so that should be your default choice. However, bracket notation has its own uses. Sometimes you don't know the name of the target property until the runtime. For example, in our user interface, the user might be selecting the name of the target property. In that case, at the time of writing code, we don't know what property we're going to access. That is going to be selected at runtime by the user. So we might have another variable somewhere else, like selection, that determines the name of the target property that the user is selecting, and that can change at runtime. With this, we can access that property using the bracket notation in a dynamic way. So we pass selection here, and we get the same result. Okay? Now, if this is confusing, don't worry. You're going to see this again in the future as you gain more experience with JavaScript. For now, just stick to the dot notation because that's cleaner and easier. Next, we're going to look at arrays, dealing with a list of objects. For example, the list of products in a shopping cart, or the list of colors the user has selected. In situations like that, you use an array to store that list. Let me show you how. So here I'm going to declare another variable called selected colors. Note that I'm using a meaningful name. I don't have SC or some other weird name. Selected colors. Now we can initialize this and set it to an empty array. So these square brackets are what we call array literal, and they indicate an empty array. Now we can initialize this array and add a couple of items like red and blue. Let's log this on the console. So console, the log, selected colors. Save the changes. So here's our array with 2 elements. We can expand that. Note that each element has an index, and that determines the position of that element in the array. So the index of the first element is 0, and the index of the second element is 1. So if you want to access an element in an array, we use this index. Here's how. For example, let's say you want to display the first element in this array. You use the square brackets and then specify the index. Save the changes, and now we have red. Now, earlier I told you that JavaScript is a dynamic language, so the type of variables can change at runtime. The same principle applies to our arrays. So the lengths of arrays, as well as the type of objects we have in an array, are dynamic. They can change. So on line 2, we initialize this array with 2 elements, right? Now, on line 3, we can add another element to this array, so the array will expand. So let's say selected colors of 2. That means the third item in this array is going to be green. Now, let's display this array on the console. So we have an array with 3 elements. So the length is dynamic. It can change. Also, the type of objects we have in this array is dynamic. So unlike other programming languages where every item or every object in the array should have the same type, in JavaScript, we can store different types in an array. So we can make the last element a number. Save the changes. Now we have 2 strings and a number. So the objects in the array as well as the size of the array are dynamic. Now technically an array is an object. So just like the person object we defined in the last lecture, it has a bunch of key value pairs or properties that we can access using the dot notation. Let me prove that to you. So here on the console, let's look at the type of selected colors. So the type of this array is an object. So an array is an object in JavaScript. So here on line 4, we can look at the properties of this array or this object using the dot notation. Look, these are all the properties defined in arrays in JavaScript. So every time we declare an array using square brackets, that array will automatically receive these properties. We didn't explicitly define them. They're just somehow magically inherited from somewhere else. We're going to learn about that later when we talk about prototypes. Now in this lecture, we're going to look at one of these properties. That is the length property. This property returns the number of items or elements in an array. So save the changes. You can see we have 3 elements in this array. Now later in the course, we have a comprehensive section about arrays. You'll learn about all kinds of operations you can perform on arrays. For now, all I want you to take away is that an array is a data structure that we use to represent a list of items. We have learned about objects and arrays. Now let's take a look at functions. Functions are one of the fundamental building blocks in JavaScript. A function is basically a set of statements that performs a task or calculates a value. Let me show you a couple of examples. So I'm going to declare a function using the function keyword. Now we need to give it a name. Let's call that greet. After that, we need to add parentheses. That's part of the syntax for declaring functions. Logic in our application. For example, the logic for this function should be to display a message on the console. So here we can add console.log hello world. Now note that here we have a statement, so we terminate it with a semicolon. But when we are declaring a function, we don't need to add semicolon at the end because we are not declaring it like a variable like this. Okay? This is a function declaration, right? So now we have a function. We can call this function like this. So we add the name of the function and parentheses again, and then semicolon to indicate that this is a statement. Save the changes. Now we have hello world on the console. But that's pretty boring. Why would we do this? Let me show you how to make this more interesting. Our functions can have inputs, and these inputs can change how the function behaves. So let's say instead of displaying hello world, we want to display the name of the person here, like hello John. So we can add a variable here in between parentheses. We refer to this variable as a parameter. So this greet function has one parameter called name, and essentially name is like a variable that is only meaningful inside of this function. So inside of this function, we can work with this name variable, but it will not be accessible outside of this function. Now name is an input to this function. So instead of displaying hello world, we can display hello, then add a plus here to concatenate two strings. So we can add name after. Now, when calling the greet function, we need to pass a value for the name variable or name parameter more accurately. So we can pass John here. Now we refer to this as an argument. So John is an argument to the greet function, and name is a parameter of the greet function. That's one of the things that a lot of programmers don't know. They don't know the difference between a parameter and an argument. So a parameter is what we have here at the time of declaration, but the argument is the actual value we supply for that parameter. Okay? Now let's save the changes. So we have hello John. Now we can reuse this function, but with a different input. So we can copy this line here and change John to Mary. Save the changes. Now we have two different messages on the console. Now a function can have multiple parameters. So here we can separate parameters using a comma. So let's add another parameter like last name. Now we can change our console.log, add a space here, and then display the last name. Now, when calling this greet function, we should pass another argument for the last name, right? But let's see what happens if we don't do this. So I'm going to save the changes. See what we got? Hello John undefined. Because as I told you before, the default value of variables in JavaScript is undefined. So because we did not pass a value for the last name, by default, it's undefined. So I'm going to pass another argument here. We separate them using a comma, John Smith. And we don't need the second call to the greet function. Save the changes. Now we have hello John Smith. Code on line 3. All these concatenations are kind of ugly. They're getting in the way. Later in the course, I'll show you how to use template literals to clean up this code. For now, don't worry about it. Let's look at another example of a function. So this function we have here is performing a task. So performing a task. Its task is to display something on the console. But sometimes our functions might calculate something. So Here is an example of a function that calculates a value. So again, function. Let's call this function square. This function should take a parameter. Let's call that number. Now we need to calculate the square of that number. That is number times number. Just basic math, right? Now we need to return this value to whoever is calling this function. For that, we use the return keyword. That's another reserved keyword, so you cannot have a variable called return, okay? Now, instead of calling the great function, let's call the square function. So square, we pass 2. Now this returns a value, so we can use that value to initialize a variable. For example, we can declare another variable called number and set it to a square of 2. And then we can display that on the console. Save the changes, so we get 4. Now, in this particular example, we don't necessarily have to declare a separate variable if all we want to do is to display the square of 2 on the console. We can exclude this variable declaration and simply pass square of 2 to console.log. So when the JavaScript engine executes this code, first it's going to call this function, it will get a value and then pass that value to console.log. Let's save the changes and look, we still get 4. Now I have a question for you. How many function calls do you think we have in this code? We have 2 function calls. Square of 2 is one function call. Let me delete this temporarily. But console.log is also another function call, right? Because here we have parentheses. So we're calling the log function, which is defined somewhere, and passing an argument. We can pass a simple string like hello, or we can pass an expression. That expression can be a call to another function like square of 2. Okay? So this is the basics of functions. Again, later in the course, we have a comprehensive section about functions. For now, all I want you to take away is that a function is a set of statements that either performs a task or calculates and returns a value. A real-world application is essentially a collection of hundreds or thousands of functions working together to provide the functionality of that application.